Hey, also this is Math 116, section 6.1. This section is going to be simple interest, and this whole chapter is going to be financial formulas. The math in this chapter is pretty easy. It's really just a matter of reading and using a calculator. And so you'll see we have sort of some terms we've ran into, but we're getting them a bit more defined here. By the end of this chapter, we'll have like a full page front and back, basically, of formulas and terms. So let me start with interest. So for simple interest, all it is you're going to borrow some money, and then each year you're going to pay back a percentage of that money. There's no compounding. There's no interest on the interest. It's just a percent of the original sum. So in that case, interest is the principal times the rate times the time. The future value, so that's how much money you're going to have to pay back, is S, and this is going to be the abbreviation for that, but it's S equals principal plus interest. And so this is the money that you put in, then you get this interest payment, and that's how much money would be in the account that time later. Another way we could write that is S equals P plus PRT, and that version is mostly what we'll use throughout here. So this first one, $13,000 is invested for 7 years at an annual simple interest rate of 16%. So if this was like on a test, simple interest rate is what tells you that it's in 6.1. So that's going to be kind of the first distinguishing. We have a lot of distinguishing to do in this chapter. There's a bunch of problems that sound very similar. So for 6.1, we're going to see the word simple somewhere in the directions. So 13,000 is invested, so that's principal. So P is 13,000. For 7 years, T is going to be 7, and the rate is 16%. So in this problem, it maybe doesn't seem like you really need to make a list. You'll see as we go forward in these problems, or at least in the chapter, we'll end up with a list of like 6, 7, 8 things. So this will be a good habit to get into. So in this case, we're looking for how much interest is earned, so that's I, which equals PRT, and we have all three of those. So 13,000 times 16% times 7 years. And so then I equals, comes out to 14,560. And then I'll just also point out this is capital I. Later in the chapter we're going to get a lowercase I. That's a different thing. So definitely write that as a capital I. What is the future value of the investment at the end of 7 years? Okay, so future value, in this case we've already calculated the interest, so we're just going to do principal plus interest. So S equals principal plus interest. Principal was 13 grand. Interest was this 14,000. And add those together and get 27,560. Okay, number 2, $5,000 is invested at 9% simple interest. How long does it take to be worth $9,500? So 5,000 is invested, so that's P. 9%, that's our R. And notice with these I am switching from percent to decimal to do the math with them. How long does it take? So that would be T, and that's what we're looking for it to be worth 9,500. So for S to be 9,500. And then we're back to our, like I said, S equals P plus PRT is generally going to be the most useful form of that formula. And we'll just plug in everything, and we have P, we have R, and we have S, so we can solve for T. So S is 9,500, P is 5,000, 5,000 again, R 0.09, and T. So the first thing I do is subtract over this 5,000 from both sides. So So over here, that's going to give me 4,500 equals 5. Actually, let's go ahead and just go 5,000 times 0.09, and that would be 450. And then from there, we'll divide over the 450. And it looks like T is 10, so 10 years. Okay, number 3. If you want to earn 15% simple interest, so R is 15%, how much should you pay for a note that will be worth $47,250 in 10 months? So this is what the note will be worth, so that's going to be a future value. So that's S equals the 47,000. And then for the 10 months, because this is an annual rate, we need to put this in terms of years. So 10 months is 10/12ths of 1 year. So anytime we have months, we just do number of months over 12. So even if it was 18 months, we just say 18 months over 12, that'd be 1.5 years. And then we are looking for how much should we pay for it. So that's the principal, how much we're putting in. So again, S equals P plus PRT. And we know S. We do not know P, so P plus P, R 0.15, and T is this 10/12ths. I put this in the calculator, and I got 0.125 P for that. And then these are both like terms. This just has an invisible 1 in front, so I can put those together and get 1.125 P, and then divide that over. So I got P to be $42,000. Okay, and then these next 3 are the ones I'd have you guys try. So number 4 is if you borrow $900 for 6 months at 14% annual simple interest, how much must you repay at the end of the loan? So how much you got to pay back, that's the future value. So that's what we're looking for. We're borrowing $900, so that's like the principal, that's the starting amount. For 6 months, so T is going to be 6 over 12, or 0.5, half a year. And then R is 14%. And so in this case, we're just looking for S, so it'll be 900 plus 900 times 0.14 times time. Let's call it 1/2. And put all that in the calculator, and I got $963. So the next one, if I want to earn 15% simple interest, so R is 15. How much should I pay for? So that's the principal, that's the starting amount. That's what I'm looking for. A note that'll be worth $20,250. So that's our future value in 10 months. So T is 10 over 12. And so again, we have S equals P plus PRT. And we're solving for P this time, so we'll put in the 20,000 and 0.15 times 10 over 12. And then put this in a calculator, and I got 250 P. I think that came out to 0.125 again. And so then again, with that invisible 1, that makes this 1.125 P. And then I just divided this over, and that gave me a principal of $18,000. Number 6, last one. So 5,000 is invested, so P is 5,000. 7%, R is 0.07. How long does it take? So we're looking for time to be worth 74.50. So that is our future value. And so future value 7450 equals the principal 500 or 5,000 plus principal times rate and then times time. And so we will subtract over the 5,000. So we're trying to solve for t now. And it's going to leave 2450 equals, and then this times this would be 350t. And I can just divide that over, and I got t to equal 7.